Perfect. So good afternoon, good morning, good evening, or good whatever is in your time zone. And welcome to this instance of the Antrea community meeting. Today is, at least in this time zone, is Tuesday, November the 22nd. And for today, we have an update from Chan regarding the API changes for layer 7 network policies. So, Chan, yeah, you're already sharing the screen, so please go ahead.
Thank you, Salvatore. And thanks again for attending this meeting. And after receiving a lot of useful feedback in the last two community meetings, and after some more investigation and discussion with Jianjun, I would like to share that we make a change to the Layer 7 policy API. And now our proposal is to merge the Layer 7 policy to existing Layer 3 and Layer 4 policy. And we made this change because of several considerations, including that first, it is easier to manage all security in one place. If with a separate Layer 7 policy, and maybe we will need another cluster scoped Layer 7 policy, user will have 5 APIs to manage the security of their workloads. So it sounds a little bit complicated. And second is, after receiving many feedbacks about use cases in the last community meeting, we found that if we have separate APIs, it would be more. It would need more. It would require the user to be more careful when they want to use the 7 policy, especially when they want to, their workload need to use multiple protocols. And if some of the protocol are not supported by the 7 feature yet. For example, with separate Layer 7 API, because the their policies are enforced in different stage. So the traffic must be first allowed by Layer 3 and Layer 4 policy. Then it must be allowed by Layer 7 policy. But some protocol are not supported by Layer 7 policy. For example, MySQL or Redis, some database protocol. But we will have to scope the traffic. We will need to define the scope of the traffic that will be handled by Layer 7 policy. Otherwise, they will still be dropped by Layer 7 after enforcement of Layer 4. So, but on the other side, the user must guarantee that the traffic must also be allowed by Layer 4. So they need to consider, they need to be very careful to make the Layer 3 and Layer 4 and Layer 7 to work together. And there has to be some redundancy for the rules. And the third reason is it is more consistent with existing solutions if we embed the Layer 7 protocol into Layer 3 and Layer 4 policy. We investigated several existing solutions that support Layer 7 firewall, including NSX and Cilium and Calico. Although their behaviors are a little different, but the API design is very similar. So to be consistent with existing solutions and give user a consistent experience. So we are also following this style. And after making this change, there has to be a few limitations because of the restriction of implementation. For example, as you can see from the new data structure of the network policy rule, we have added one layer 7 protocols field to the existing layer 4 rule. And but its meaning is a little different from others. For example, for this port and the protocols, their relationship is OR. It means that you could use ports to define the port the traffic should match, or you could use protocols to define the other non-TCP and non-UDP protocols, such as SMP and IGMP. The traffic could match. It means either of them is matched. The traffic will take this action. But for layer 7 protocols, because it needs the layer 4, it needs the layer 4 port to scope the traffic. It doesn't mean their relationship is not or, but and. It means the traffic must first match the ports field, and then it will be sent forwarded to an layer 7 aware engine for protocol detection and rule enforcement. So both of them should be matched. And because we support only allow list for now, so with this field being set, the action can only be allowed at the moment. This limitation exists in other solutions that support layer 7 level C2, because most of the 7 engine supports only whitelist or blacklist, not mixed priority style rules. And as long as the traffic match the layer 4 criteria, the traffic will either be allowed by the if they match the layer 7 protocols, otherwise they will be dropped. So any rule after a layer 7 rule will not be enforced if the traffic already matches the layer 4 criteria. So this is the limitation that we have to have. We have to have because the implementation restriction, but it shouldn't affect the actual use case. For example, I listed 2 use cases we received in the last community meeting. The first is that for an application, I know that my workload only serves as a HTTP server. So what I want to do is I only want to let clients to accept my workload using HTTP protocol, because this is the only one it's supposed to be used. So this is port. This could be port agnostic. We could define such a rule to allow only HTTP request, and it must match the host name, and regardless of the transport protocol, of course, is TCP, and regardless of the port being used. So this is one use case, and another use case is I know my application will depend on some other services. One is a database service, Redis service as an example. I want to allow its egress communication with this port, and I know it will also relies on a REST API, external REST API. So I know that it will use the TCP 80 port, or it could be any other port, and it could even and it doesn't not need to specify the port. But because the TCP, this rule is before the layer 7 rule, so the the database service traffic will first be allowed, then all TCP traffic or all TCP traffic with this port specified can only be HTTP. And my application may also need to access DNS service. So I could also specify another UDP port. This could also be moved behind this layer 7 rule. Then we don't need to specify this layer 4 criteria, because all traffic except these two already defined rule will be dropped if they are not HTTP. But if you specify another layer 4 rule after the layer 7, and the layer 7 only affect a specific port traffic, you will need to define another drop rule for other traffic that are not selected by this layer 7 rule. So this is a use case of port specific protocol detection. It will only inspect traffic to port 80. So I think this API change should meet the requirement of all use cases. And so there is already a PR that implemented this change. And any comments are welcome.
Tran, I'm really sorry. I joined the meeting late, so I probably didn't catch the first part. But if we merged this into the layer 4 policies, does it mean that right now the layer 7 protocols or the layer 7 rules are no longer implicit isolation?
Sorry, let me share back my screen. Can you repeat your question?
Yeah, so I remember, when layer 7 being its own API, it's like Kubernetes network policy, where if you specify layer 7 protocol, then anything selected will be implicitly isolated. So when you move this to the layer 4, how does the isolation work though?
It depends on whether you also set the layer 4 port. If you let's take these two examples. If you don't specify the layer 4 port, it means that this is a port agnostic protocol detection. All ingress traffic must match HTTP protocol. No other traffic will be allowed, regardless of the port being used. You could use port 80 to access HTTP service. You could use other port as well. But regardless of the port being used, they must be HTTP request. And if you want to only to say you know that your application will only run on listen to a specific port, then you could also define the scope of the traffic that the layer 7 engine should inspect. In this example, it will only inspect the traffic to TCP 80 port. No other traffic will be inspected by the layer 7 engine. So this isolation happens to this port only. If you use a port, for example, 8000 to use HTTP, then it will be dropped by this rule instead of this rule, because it's not this rule's responsibility to inspect another port.
But in the case of the first use case, when you have this specific ingress rule, it means that for whatever selected in the apply to, which is hidden here, will have the implicit isolation effect, basically.
Yes. As explained by the comment, I will also document this behavior that once because you didn't provide a layer 7, a layer 4 criteria. If we don't have this, it means that all traffic will be allowed, right? But if this is a pure layer 4, so actually the layer 4 criteria is used to scope the traffic that will be inspected by the layer 7 engine. So this rule already will handle all incoming traffic. Yeah, and the isolation will, of course, will happen because it will only be allowed once this match. And if this layer 7 protocol is not matched, they will be dropped. If you don't want the isolation for all your incoming traffic, you should specify the layer 4 criteria. For example, you want the layer 7 engine only to handle traffic to TCP 80, then you should provide something like this.
Okay, but I'm just worried about not only the meaning of it, but also how do we implement this? Like right now on the layer 4 case, this will be as is, right? And right now, when we introduce the L7 protocol, I do feel like this is a huge change in the potential semantic meaning of the rule.
Yeah, I understand. That's also why it was not proposed in this way in the beginning. But after more discussion, we found that even if we have a separate layer 7 policy, there has to be some limitation, and there has the meaning of the we may have to do something in layer 4 as well to make they work together, and we will also need to such layer 4 criteria to scope the traffic that will be handled by layer 7 engine. So it's not the best, but it sounds better than the separate API. Yeah, I understand your concern. But from my investigation, that other solutions that use this style also has this limitation. Even they support allow and deny drop, and they support the priority, but actually the priority does not even play a role in the when the rule is layer 7. Yeah, but at least we in our implementation, we still respect the priority, and it's just that we will have a default deny when the traffic is already handled by layer 7 engine.
Okay, let me because you were saying that you have a PR up. Let me first look at that, and I'll if I have more comments, I'll just post it there then. Thanks.
Sure. Thank you for your comments.
Hello, Chen. I have a small question. In my understanding, I think the layer 4 rules is used to filter the traffic to layer 7 engine. And then if we don't limit the layer 4 traffic, then all related traffic will be forwarded to layer 7 engine, and only the rule defined by layer 7 rule will be allowed, and other traffic will be dropped. Is that my understanding right?
Yes, yeah, it's correct.
Okay, thanks.
Okay, if no other questions, So I think we could go to the next topic.
Thanks, John. No, I don't have any other question as well. I mean, I need to digest a little bit the change that you're making in DPI. I understand the rationale, and I mean, it's very well understood. You know, I'm not really considering the impact from a implementation or from an implementation perspective, because in a way or another, we'll find a solution there. One aspect that probably we want to consider here is what do we need to document for users? So is there any caveat that we need to document, or it would be like just standard Antrea network policies with an addition? Because from what you told me, I think there are some aspects that users must be explicitly aware of, right, when they want to configure layer 7 network policies.
Yeah. We will enhance the user experience in two ways. The first is we will have validating webhook configuration to guide the user to create legal layer 7 protocols. For example, when they specify the layer 7 protocol, we will validate the action can only be allowed. And we could also check the meaning, check the relationship between the layer 4 criteria and the layer 7. For example, when it's HTTP, I think it does not make sense to use UDP protocol to specify UDP. So we could also do such validation. And another second is we will document the limitation in the Antrea policy while using a separate section about layer 7, and document the what it means when layer 7 protocol is specified alone, and what if they want to limit the layer 7 rule only applies to a few traffic to a specific port, and the default job behavior we will document them clearly.
Okay, thanks for the clarification. So before we move to the next topic, is there any final question for Chan? 3, 2, 1, and now it's time to move to the next topic, which we don't have on the agenda. Lan, I don't know, do you have any update for policy only multi-cluster for today?
Yes, I think I will give another update for this topic.
Great, go ahead.
Yeah,
please.
yeah. Can you see my screen?
Yes.
Okay. Hello, everyone. I think last time I gave an overview of current design about the multi-class traffic when we want to run it in a network policy only mode. And in this page, it's actually a little recap about what we have in the in-cap mode. You know that in in-cap mode, when we have those, let's talk the in-class traffic, it will go through the tunnel, right? Even it's in-cluster traffic or even it's cross-class traffic, all traffic will goes to the tunnel interface, and it's all controlled by our entry agent. Our entry agent is the primary CNI, and the multi-cluster traffic. One thing that I like to highlight is that the multi-class service, for example, here, it's we call it multi-class service, and it has some endpoints. The endpoint is the cluster IP from other member clusters. For example, here you can see the service full. It has B, the IP is 192, but it's not the endpoint of the multi-cluster endpoints. The multi-cluster endpoint will be the service cluster IP. So you will see that when you are trying to access from the port A in the member cluster A, and the port A actually access this IP. This IP is cluster IP, which is generated by the local member cluster A, and it will have a new endpoint. This endpoint will be maintained by Antrea multi-cluster. The endpoint will be the remote service cluster IP. So here is which I like to highlight before we move forward. And one thing, as I mentioned, all traffic is in the tunnel when we have it in the in-cab mode, right? But now we like to, run those traffic in network policy only mode, and in network policy on mode, Antrea is no longer the primary CNI. So as you can see here, the assumption is no longer met, and it's no tunnel interface, and it has no tunnel between nodes, even in cluster. So even we set up those tunnels between different member cluster here like this to support multi-class traffic, we still need a way to, because we have a gateway in each cluster, member cluster, we need to make sure that all traffic goes to the gateway first, then it goes out to other member cluster. So we need a way to let any cross-cluster traffic, which, for example, here, if you see that if the request is from port A, it need to go to the tunnel. But in network policy only mode, there's no tunnel here, and the port IP is not controlled by our Antrea side, because it's not the primary CNI, and also the pod access is actually controlled by primary CNI. Let's take the E case as an example. All the traffic will go through will controlled by the primary CNI. The corresponding roads will be set up, so the pod actually will not go through the tunnel. One thing is there's no tunnel, right? And another thing that all level 3 roads will be added by the primary CNI, so we are not controlling the traffic anymore. So we need to resolve this gap. And last time when I showed the gap, and we found that we need at least to do those changes in the network policy only modes. One thing that we definitely need a tunnel interface. Of course, it's for cross-cluster traffic only. For local cluster traffic, we don't want to impact them. And another thing that we need to set up the roads between the gateway and the general node, so we can make sure that all cross-cluster traffic can be forwarded from or routed by the gateway only, right? And the next thing is that which is a new finding that last time I missed. I think we also need to, update those containers interface MTU, because we have the tunnel interface here. And for any cross-class traffic, we need to reduce the MTU so it cannot be dropped when there is a large package. So for now, I think this is also another change we need to make in the Antrea agent. And actually, since last community meeting, I think the first design, which is a little complicated, and we have a follow offline discussion with a few people, and here actually comes up a new option. The option A is the one which I introduced the last time, which is trying to use a contract connection track module to, to save those tunnel source tunnel IP to make sure the gateway can know which parts traffic should be forwarded back to the source node. But after a few discussion, we think that it might be simpler to just create a level 3 forwarding, which you can consider that it's as pod routes inside of the OVS instead of let it go controlled by the primary CNI, right? We need to capture those traffic before it goes out and controlled by the primary CNI. So we need to add a level 3 forwarding rule for each pod. I think the first option, it's the original purpose is to trying to reduce the open flow rules because, if there are lots of pods, if we set up then each pod in the level 3 forwarding, it might be a huge number. But after a few discussion, we think that one thing is that the CT module will introduce some performance issue, or we say the latency, and actually in the network policy only mode is usually running in the public cloud, and the pod number should be not so big. So actually, even we add one rule per pod, it should be acceptable. So actually, I did a performance test. Later, I will show the data. So here is actually the option A, which I think I have showed this last time. And the main issue is that in the difference that in the in-cap mode, let's go back to sorry. In the in-cap mode, I think we have. Oh, sorry. Let me go back to the. Okay, in the in-cap mode, between different nodes, it's actually based on the pod slider to determine which node it should be goes to, right? But in the network policy only mode, we don't have such rule, and so in the option A, and we need to set up those pod routes between gateway and the general node. And in my original design, I was trying to set up those pod routes only for those exported service. And so it can reduce the number of the open flow rule. So here is the original proposal. And in the original proposal that we also use the CC label to save the source tunnel IP of the request. You know that when we have a request package from general node and from a pod on a general node to the gateway, the reply package won't be able to know which node it should be forwarded back to. So we use the CT label to save the request package source tunnel, and after the reply package is back, we use a CT label which we have saved to match the destination, and then we can set the destination tunnel. These two are the two parts of the option A, and it's actually it's only one goal is to set up the pod routes in the gateway to make sure the gateway know how those cross-class traffic can be forwarded to the original node. But after a few discussion, we think maybe this only this row table is enough to set up those pod routes. As you know that we just need the level 3 forwarding table and add one row for one pod. Even though we add all road or each rules for one pod, and every pod, as long as it's not running in the gateway, it will have a corresponding rule to tell that, for example, here is a pod, original pod, which we can say it's a client pod's IP. And when its a pod is this matched this IP, and we will set the right tunnel here. And the only thing we need to do is to watch the pod event to set up this kind of rule. The difference between the option A is that the option A, we might not need, there might be, won't be so many pod rules, but in this option B, we may have one rule for one pod. So when the pod is number is big, then we will have a long list here. But after, I think based on our experience, we think that the performance or the latency introduced by this rules number should be acceptable. So there are two options, and I did some performance based on these two options. Actually, you can see that in option A, or the original design, and the option B in the TCP type string type of test, it has not much difference, I think. But for these two, it's actually has a slight improvement if we goes to the plan B. Sorry, the option B. Of course, the option B, I only add one rule for the pod IP, so it's actually no huge open flow rule list in the environment. So the number might be not so precise, but it can tell us that if we don't have the CT label in the process, it may help on the latency and help to increase the transaction number. Yeah. So we plan to go to the option B, and currently the code is almost done, and I'm still trying to do those verification. And during this verification, I think we still have one thing remain here. It's you know that we have a stretch now policy on the development, and after a few verification, I think when the endpoint of the multi-cluster is the local service cluster IP, and the client pod is trying to go to the local service backend in the same cluster, actually the pod traffic won't be go to the tunnel traffic. If we didn't do anything regarding this part, the traffic will go through the gateway. The connection is okay. The service is accessible, but it's not through the tunnel interface. So it will be a problem to support the stretch channel policy in this module. And I'm thinking that it's maybe this is a gap between current implementation. And if we want to stretch this now policy on network policy only mode, and we need to do more things and do more investigation on these parts. Yeah, I think this is the one problem remained. I don't know if any other team members have any suggestion on this part or any opinions or question.
No, thanks a lot for your presentation, Lan. At least no question from my side. We'll need to find a solution for stretch network policy support, because I still thinking as a user, it feels rather awkward if we have a network policy only multi-cluster, and then we are not able to support stretch network policy in that modality, in that mode. So yeah, we'll need to figure out a solution for that. And I don't know if Yang and Grayson already have some idea.
Yeah, I think, yeah, Yang, do you have any comments on this one? I think today I actually talked with Grayson, and we may need to do more verification regarding this.
Okay, cool.
I don't
Thanks.
have any. No, sorry, I don't have any comments on it now. I probably needed to look at it a little more.
Okay, sure, thanks.
Yes, and yeah, also since currently, although the client and the endpoint of the service are on the same node, the traffic are still going to the tunnel. So maybe we should create a situation that we can verify if the traffic goes through the gateway, what will happen.
I think if the traffic goes to the gateway, the tunnel ID should be lost, I believe. Right. I don't know if Xuan or Yang have
since
any.
we store, yeah, we store it in the generic header, so.
Yeah, so I think we
Yeah.
still need to guarantee that the traffic goes to the tunnel interface, right?
Yes.
Yeah, okay.
As long as we are using the tunnel ID to store the label identity.
Yeah, okay.
Yeah.
Okay, got it. Thanks.
But I mean, it could be we could use some other designs, like for like like the specific scenario. We can just, if it's just in cluster, sorry, not in cluster, but on the same node, then maybe we can do something like we can consider that case specifically, and try to not use the label identity or whatnot to enforce traffic. But that could be discussed later, I guess.
Okay, yeah, sure. I think that might be a little different than I expected at the very beginning on the nail policy only mode. And yeah, I think the case is a little special. And there might be two cases in the nail policy only mode. One is the node, the endpoint is in the local node and as the client part. And another case is the node, the server pod is on another node. Maybe I think we need to verify both. And yeah, I'm not sure actually from the nail policy only perspective how we can resolve this kind of issue, or we have to set them into the tunnel interface. But if we do have some option, maybe we can have some discussion later. Yeah. Okay, thanks, Yang. And Salvatore, I think that's all from my side.
Cool.
Thank you.
Thanks a lot, Lan. So we don't have any other topic scheduled for today. So I don't know if anyone wants to bring up something for discussion. If you want, please go ahead. Now it's time for open discussion. Well, it's fair to say that probably there are no other topics for today. In that case, I would like to thank all the attendees for attending to this meeting, and in particular thank Chan and Lan for presenting about layer 7 network policies and network policy only multi-cluster mode. So thanks again for your presentations, and I would like to wish everyone a good day, a good afternoon, or a good night. Thanks for attending, and see you in 2 weeks' time. And for those based in the US, happy Thanksgiving.
Thank you.
Cool.
Bye-bye.
Bye. Have a good one.
Okay, bye.